Time feels steady, predictable, unchanging. But in the universe, time is flexible. It bends, stretches, slows, and even nearly stops in the presence of enormous gravity or extreme speed. This strange behavior is called time dilation, one of the most mind-bending truths in physics. And today, we go inside the phenomenon that reshapes reality itself. Welcome to Cosmicnova. Today we step into a world where time moves differently. Most of us think time is the same everywhere. 1 second here equals 1 second anywhere. But Einstein discovered the opposite. Time is not universal. It changes depending on your speed and gravity. Two people experiencing different environments can age at different rates. And this isn't theory. It's a proven physical effect. The closer you are to something massive, like a planet, star, or black hole, the slower time passes for you. This is called gravitational time dilation. It means astronauts in orbit actually age slightly faster than people on Earth, because they're farther from Earth's gravity. There's another way to slow down time: move faster. The faster an object travels, the slower time flows for it. If you speed close to the speed of light, time for you nearly freezes, while years pass for everyone else. One of the most famous examples is the twin paradox. Imagine two twins. One stays on Earth, and the other travels close to the speed of light. When the traveling twin returns, they are younger because time literally passed slower for them. This paradox isn't imaginary. It's what reality predicts. Time dilation becomes extreme near a black hole. The gravity is so strong that time slows dramatically as you approach the event horizon. Minutes for you could be centuries outside. In the most extreme case, time can nearly stop entirely. If someone watched you fall toward a black hole, they would see you slow down, then freeze in time just above the event horizon. From your perspective, you would continue falling normally, but the outside universe would speed up. Galaxies would evolve. Stars would die. Time would race. You don't need a black hole to experience time dilation. GPS satellites must correct for time dilation every second. Otherwise, your phone's navigation would be off by miles. Time dilation affects your daily life, even if you never notice it. But these examples are just the surface. Time dilation gets stranger and more powerful the deeper we go. What happens inside a neutron star's gravity? What if we could travel close to light speed intentionally? And could time dilation allow us to journey into the future? To find these answers, we must step into the extreme edges of physics. Time dilation isn't a science trick. It's the universe revealing its true nature. The faster you move, the stronger the gravity you feel, the more time bends. In ordinary life, the effect is tiny. But near extreme objects or at incredible speeds, time becomes flexible, stretchable, and shockingly different. Neutron stars are one of the densest objects in existence. A teaspoon of their matter weighs billions of tons. Stand near a neutron star and time would slow massively. Minutes for you could be hours or days for observers far away. Gravity bends space, and time follows. The stronger the gravity, the slower time moves. Near a neutron star's event horizon, if it had one, time would crawl almost to zero. This means you could look out into the universe and watch stars evolve, galaxies rotate, and cosmic events play out in fast motion, all while barely aging. The stronger the gravity, the slower time moves. Near a neutron star's event horizon, if it had one, time would crawl almost to zero. This means you could look out into the universe and watch stars evolve, galaxies rotate, and cosmic events play out in fast motion, all while barely aging. The fastest clock in the universe isn't a real clock. It's a particle. Particles traveling near the speed of light age much slower than everything around them. This is why cosmic ray particles survive longer than physics predicts. They move so fast that their internal time slows down. Here's the incredible truth. Time dilation allows real time travel, but only forward. If you traveled at near light speed for 1 year, decades could pass on Earth. You would return younger than everyone who stayed behind. This is not imagination. It is predicted by relativity and confirmed by experiments. Time dilation increases dramatically the faster you move. At 90%, light speed time runs half as fast. At 99%, time runs 14 times slower. At 99.999%, time almost stops. Space and time stretch into unnatural shapes, while your own time shrinks. Imagine you accelerate to 99.99% the speed of light. Your heartbeat slows. Your biological aging slows. Seconds for you become years outside. If you kept going, you could cross the Milky Way in a lifetime, even though it's 100,000 light-years across. To you, nothing feels different. Your body obeys your local time. But from Earth's perspective, you are moving through time at a different rate entirely. Your journey becomes a trip into the far future, a natural consequence of relativistic travel. Massive objects curve space-time so sharply that they act as natural time machines. Orbit a black hole at a safe distance, and you can skip ahead in time. Stay near it long enough, and centuries could pass outside while only hours pass for you. But time dilation has a darker side. As we push deeper into relativity, we face impossible questions. Can time ever reverse? Can we step outside of time's flow? And is there a limit to how much time can bend before reality itself breaks? To answer these, we must confront the boundaries of physics. Time feels smooth, but under extreme physics it begins to shatter. When gravity becomes overwhelming or speed approaches the speed of light, the rules of time start bending in ways that almost defy reality. And at the very edges of the universe, near singularities, inside black holes, and within the earliest moments of creation, time may not behave at all. Theoretically, time can nearly stop, but only under impossible conditions. Near a black hole's event horizon, gravitational time dilation becomes infinite. From the outside, you would appear frozen forever, while the rest of the universe rushes toward its distant future. But from your perspective, time flows normally. Time only stops from someone else's viewpoint. Inside a black hole, physics collapses. Space and time switch roles. Space becomes time-like, and time becomes space-like. This means once you cross the event horizon, moving forward in time leads you inward toward the singularity. You cannot avoid it. Time becomes a path to destruction. At the singularity, the laws of physics break down. Gravity becomes infinite, space-time curves infinitely, and time itself becomes undefined. This is the ultimate limit of relativity, a region where our understanding collapses and quantum gravity must take over. Physics allows many strange possibilities, but time reversal remains uncertain. Some equations permit it. Most physical processes do not. Entropy, the natural tendency toward disorder, pushes time forward. Reversing entropy, reversing motion, reversing time may be physically impossible for the universe we live in. In the first moments after the Big Bang, time didn't flow like it does now. Space was compressed, energy was infinite, and time moved in ways we cannot fully describe. In a sense, the universe didn't begin. Time itself emerged from that state. If humanity ever faces an extinction event, an asteroid, a gamma-ray burst, or the heat death of the universe, time dilation could let us escape into the far future. By orbiting a black hole or traveling near light speed, humans could skip millions of years and reach a safer cosmic era. Future civilizations may use time dilation like we use airplanes, to travel safely across long cosmic distances, to migrate to distant star systems, or to preserve knowledge across millions of years. Time dilation isn't a limitation. It's a cosmic tool waiting to be used. But with all these incredible possibilities, one truth remains. Time is personal. No matter how much physics bends it, twists it, or reshapes it, the time we live, the moments we choose, The stories we create, they are ours. Time dilation shows us the universe is stranger than we imagined, but also more extraordinary. Time is not a simple river. It's a living, changing fabric that stretches across the universe, shaping stars, shaping worlds, shaping us. And the more we explore its mysteries, the closer we get to understanding the true nature of reality itself. Thank you for watching Cosmic Nova. Until next time, stay curious, stay inspired, and keep exploring the universe.